In this video, I'm going to be showing you how to calculate probability tree diagram questions. So in this question, we're told John has 9 coloured beads in a bag, 4 of the beads are black and the rest are green. So we know straight away now that 5 are green. He removes a bead at random from the bag, notes the colour and then puts the bead back. It's very important that we're told that he puts the bead back because now the probability will stay out of 9 for the whole question. He then chooses a second bead and we need to draw a tree diagram showing all possible probability outcomes. So let's have a look at the first choice. We're told it's out of 9 and we're told that 4 are black and then 5 are green. So then he knows the colour, then he puts the bead back, so then the probability is still out of 9. And now we'll have the exact same probabilities now in our branches. So we have 4 for the black one and then 5 for the greens. Now to get our probabilities in tree diagrams, you need to multiply along the branches. So for the first one there, the probability of black, we'll do 4 out of 9 times 4 out of 9. So we have 16 over 81. Next one, the probability of black and green, we have 4 out of 9 times 5 out of 9. So we have 20 over 81. Next one, the probability of green and black, 5 out of 9 times 4 out of 9. That gets us 20 over 81. Lastly then, probability of green and green, 5 out of 9 times 5 out of 9. That gets us 25 over 81. So now, it's worth noting now that all the probabilities we have at the end, so if we add up 16 over 81, 20 over 81, 20 over the 81 and 25 over 81, I will end up with 1. Because remember, probability 1 is the max. So let's have a look at part B now. Calculate the probability that John chooses 2 different colours. So for 2 different colours, it can't be the top one black or the bottom one green. So it's these 2 middle ones here. So black and green or else green and black. So we have 20 over 81 plus 20 over 81. So that is 40 over 81. Next one now, so at least one green. So let's have a look where there's at least one green. We have this one, this one, and this one. So let's add these up. 20 over 81 plus 20 over 81 plus 25 over 81. And adding those up gets us 65 over 81. Another way we could have done it is had a look at the choice where it's only black. So there's 16 over 81. And we could have done 1 minus 16 over 81, which as well would have got us 65 over 81. So 2 ways to do it and you would have got the same answer. Let's have a look at another one. So in this one, we're told that Helen passes through 2 sets of traffic lights on her way to work. The probability that she stops at the first set is 0.3. So let's put that into our diagram straight away. And if the probability that she stops is 0.3, then the probability that she doesn't stop has to be 0.7. Because these probabilities have to add up to 1, remember. Then the next bit of information, the probability that she stops at the second set is 0.2. So let's put that in. And then if that's the probability that she stops, the probability that she doesn't stop has to be 0.8. because remember, these add up to 1. Now, we need to draw a tree diagram to show all the probability outcomes. So we have all our branches marked out, so let's get the probabilities. So here the probability that stop, 0.3 times 0.2, that is 0.06. Probability doesn't stop, 0.3 times 0.8, that is 0.24. Next one, probability doesn't stop and stops. We have 0.7 times 0.2, that's 0.14. And finally then, probability doesn't stop and doesn't stop. We have 0.7 times 0.8, which is 0.56. So that's part A done. We have all the probabilities. Now we're asked what's the probability that she has to stop exactly once. So if it's exactly once, it can't be the top one because that's a stop and a stop. Can't be the bottom one either because that's not stopping at all. We want it to be only one stop, so that would be our middle ones. Let's add these now. 0.24 plus 0.14, and that gets us 0.38. And that's question done. I'll go through one more. So here, Barry and Michael play a game of miniature golf, then a game of tennis. The probability that Barry wins at miniature golf is 3 out of 5. So let's mark that in straight away into our tree diagram. So we have 3 out of 5, he wins that. That means the probability of Michael winning it has to be 2 out of 5, because remember, it adds up to 1. Then the probability that Michael wins at tennis is 3 out of 5. So let's mark that in. So 3 out of 4 for Michael, so there. Then the probability for Barry at tennis has to be 1 out of 4, because again, it adds up to 1. Okay, so let's work out our probabilities quickly. So probability of Barry winning both, we have 3 out of 5 times 1 over 4, which is 3 out of 20. Probability then of Barry and then Michael, 3 out of 5 times 3 out of 4. We have 9 over 20. The probability of Michael and then Barry, we have 2 out of 5 times 1 over 4. And then finally then, the probability that Michael wins both, 2 out of 5 times 3 over 4. So we have 6 over 20. Again, if you were to add up all these, you would get 20 over 20. So then for part B, what is the probability that Michael wins no game? So you can see there, that's the same as the probability that Barry wins both. So that would be 3 over 20. So just again with tree diagrams, remember to get your probabilities, multiply along the branches, and every 2 branches, like the first one here, will have to add up to 1. Okay, any questions, please leave in the comments.